Hello everyone, it's me, Sanjay Vasu, back again for another video. This time we're going to see Cambridge Lower Secondary Checkpoint Mathematics Paper 1 for October 2021. Let's start. Question 1. Write 64 by 124 in its simplest form. That is quite simple because we just need to simplify it. So we divide by 2, it'll be 32 by 62, and that will be equal to 16 by 31. And that's the last amount we can simplify it. 16 by 31 is the answer. Question 2. Write in the boxes the correct name for each part of a circle. So first we have the perimeter of a circle, which is called circumference. Then we have center till a point on the circumference, which is the radius. Then we have 2 times the radius with a diameter. Question 3. All the rows, columns, and diagonals add up to 15 in this grid. Complete the grid so that all of the rows, columns, and diagonals add up to 15. So over here, we have this adds up to 15. Now we need to make this adding up to 15. 12 plus 5 is 17. 17 minus 2 is 15. 13 minus 2 is 11. 11 plus 4 is 15. 4 minus 3 is 1. And 14 plus 1 is 15. 14 plus 5, 19. 19 minus 4, 15. 13 minus 4, 9. 9 plus 6 is 15. Now if you want, pause the video and you can see the same structure happening again. All the rows and the columns and diagonals add up to 15. Question 4. Solve 17 minus 3x equals 2. That means 3x equals 17 minus 2. 3x is equal to 15. X equals 15 by 3, which is equal to 5. So that's the answer. Question 5. The diagram shows the first 3 patterns of a sequence made from rods. So we have pattern 1, 2, 3 over here. And we can see pattern 1 has 3, pattern 2 has 7. And if you count for pattern 3, it'll actually have 11. Or pattern 4 in the sequence. So let's see how that looks like. This. We'll just copy down pattern 3. That's pattern 3. Now we need to add another 4. So that's 1, 2, 3, and 4. So that's how you do pattern 4. B. Complete the statement. When the pattern number increases by 1, the number of rods increases by dash. Well, we saw 3, 7, 11, 15, so on. And that means add 4. C. Work out how many rods will be used for pattern 7. So if you notice, the nth term is 4n minus 1. Because n is 1, 4 into 1 is equal to 4. 4 minus 1 is equal to 3. And that's this. Substitute 2 in, you'll get 7. Substitute 3 in, you'll get 11. 4 in, you get 15. So if you use n as 7, 4 into 7 minus 1, which is equal to 28 minus 1, 27. And there are 27 rods. Question 6. The bar chart shows how students in class 7 throughout the school. Tick to show if these statements are true or false. All of these have been done for you. So we have this bar graph and we have to see if these are true or false. First one's been done. 40 students in class 7. Let's see. So we true, but there's 8 plus 14 plus 5 plus 9 plus 4. 8, 14, 5, 9, 4. If you do the math, you'll actually know that it's equal to 40. Next, 50% of those students travel by car or bus. So this is 8 and this is 14. 8 plus 14 equals 22. 22 by 40 is equal to 11 by 20, which is equal to 55. And that's not equal to 50%. So it's false. A quarter of the students walk to school. So we have a 9 for walking and 9 by 40. And that's equal to 22.5%. And quarter is 25%. These two are not equal, so this is also false. Question 7. Write 0.285 as a fraction in simplest form. So we have 285 by 1,000. Quite straightforward. Now we can simplify that by 5. 57 by 200. I don't think there's any way else to simplify this, so that's the answer. So 57 by 200. Question 8. Write these measurements in order of size from smallest to largest. 540 meters, 504 centimeters, 5.04 kilometers, 5400 millimeters. So let's convert all of these to meters. That's equal to 5.04 meters. This is already in meters. And then this is 5040 meters. This is equal to 540 centimeters, which is equal to 5.4 meters. And that means this is the smallest. Then we have this, this, and this. So let's write that down. 504 centimeters, 5400 millimeters, 540 meters, and 5.04 kilometers. Remember, you must write what is originally given in the question, in the blanks, not what you wrote for conversions. Question 9. Pierre rolls dice with 4 sides numbered 1 to 4. He also throws a coin with 2 outcomes, H or T. List all the possible outcomes one has been done for you. You may not need to use all the rows. So now dice number 1 and coin heads. Now let's do all of them with the coin flip for heads. There's 2, 3, 4, and H, H, H. There's no 5 or more in the dice, and there's no other numbers either. So now we go to tails. So we'll have another 4 tails because there are 4 values, 1, 2, 3, 4. And now, are there any more values after these? Because the dice has 1 to 4, coin has H or T. H and T are covered, 1 to 4 are covered in both of them. And that means that's the answer. Question 10. Choose one of these words to complete each sentence about the angles in the diagram. With legs corresponding, alternate opposite right. So first, angles B and F are dash angles. So angle B is here, angle F is here. What angles are they? So we can see that both of them are on the top side of the 2 lines, parallel lines. And they both are on the right side of the transversal, which means they are corresponding angles. Next we have angles D and E, so they're like this. Both of them are on the inside of this, and they're on opposite sides of the transversal. That means that they are alternate angles. Would you ask, is there a better way to remember? Well, this lines over here, if you actually turn it around, it looks somewhat like this. And that looks somewhat like an F. So remember, corresponding angles is an F, or an F-like shape. It can be inverted or rotated as well, but it can still have an F shape. And now for the alternate angles, notice that the shape is somewhat like this. If you can see, it's like this. And if you trace this, you'll see that if you turn it the other way, it'll be somewhat like a Z. So alternate angles are somewhat like a Z. Remember this. And that's all for question 10. Question 11, draw a ring around all the shapes that are congruent to triangle A. What do you mean by congruent? It means that when you rotate it or you flip it, it doesn't matter whichever you do, it still is the same shape and size. So you can see these are the same shape and size. This one's been too big, this one's too small. Well, the first one is bigger in size, and that's not the same as this, which means it's not the first one. Second one, if you flip this or you do reflection to it, it'll become like this, and that's the same as this triangle. And that means the second one is one of the congruent shapes. The third one, it's smaller. You can see that there's 2, there's 3 over here, 2. This height is different. So you can say that itself, it's smaller. And this one, actually, it is congruent because I'll draw it right here. It's the same shape. And if you rotate it 90 degrees clockwise, you'll actually get this. And that means this is also congruent to A. That's the answer. Question 12. Work out 65 divided by 9. Give your answer corrected to decimal places. Remember that we're not allowed to use a calculator and do this question. So first let's do long division. 65 divided by 9. So you have 763, and that's 2. 20, that's 2, and then 18, and that's another 2. And remember, that's a point, 7.2. And then minus 18, another 2. So 7.22. That's the answer. Question 13. Write the value in the box to make this statement correct. 28 into 10 equals 28 divided by 0.1. Because this is equal to 1 by 10, and divide by 1 by 10 is equal to multiply by 10 by 1. That's the answer. Question 14. A. Work out 2.46 into 1.3. Now let's first take out the decimal places. 246 into 13. Now we can just do this normally. And the answer we get is 3198. And that's 3198. And now we have 1, 2, 3 decimal places, which means 3.198. So that's the answer. Write the answer to part A corrected to significant figures. This means 1, 2. The third one is greater than 5 because 9, and therefore we add 1 to the second, 3.2. Question 15. Here's a right angle triangle. Sketch 2 of these right angle triangles joined together to make a parallelogram. You must mark the right angles in both triangles. First, let's draw the same right angle triangle like this, and let's mark the 90 degrees, which is right there. And to make a parallelogram, we can make another right angle triangle like this, and the right angle is right here. And now we can see here these two are the same length because they're both the same side in the right angle triangle, and these two are the same length because they're both the same side. And these two are clearly parallel because these two are equal and 90 degrees. If alternate angles are 90 degrees, like the one here, then these are parallel. And this transversal is a vertical line. And this is why it's a parallelogram. B. Sketch 2 of these right angle triangles joined together to make a kite. You must mark the right angles in both triangles. So first, what is a kite? A kite is a shape which looks... In a normal kite, these two are obtuse angles and these two are acute angles. So this is greater than 90, greater than 90, less than 90, less than 90. But now we need 2 of these to make a kite, and we need right angle triangles, which means a few of these must be 90 degrees. So I'm just going to draw a straight line in the middle. So over here, if you draw a straight line, it'll be cutting this into 2 equal sized triangles, where this angle is the same as this angle, and this is the same as this is the same as this. We can do the same thing with right angle triangles. So we can make it like this, draw the kite. Now, this obviously cannot be the right angle because it has to be a straight line. This obviously can be right angle because straight line. But these two angles can be 90 degrees because it doesn't affect the rest of the kite. So that means that we have 190 degree here, another over there, and we can draw that right there. These two are equal because it's this side. These two are equal because it's this side. And this is common to both of them, which is this side. These two are the right angles. This angle is over here, and this angle is over here. So therefore, this is a kite made by 2 of these right angle triangles. Let's move on to question 16. 16. Eva measures the mass of 25 children. She calculates the mean and the median of the masses. Eva makes a mistake when measuring the mass of one child. That child's actual mass is 5 kilograms greater than Eva's measurement. Tick the correct response to each of these statements. The correct mean is greater than Eva's mean. Must be true, must be false, or could be true or false. Well, the mean takes into account all the values, which means this 5 kg greater child is also included. And if it's greater by 5 kg, that means the correct mean will also be greater, so it must be true. The correct median is greater than Eva's mean. Well, the median takes either the middle or the middle two values. The middle if there's an odd number of values, and middle two if there's even. So over here, there are 25 children, so it takes the middle value. Out of, let's just say it's 25 children right here. And this actually, it only counts the middle around there. It doesn't count the ones at the far left or the far right, in ascending order, I mean. This child might be somewhere over here or here or here, which means it can be true or false. That's the answer. Question 17. Complete the statement using consecutive whole numbers. Dash less than root 40 less than dash. Let's first make it root something is less than root 40, and that is less than root y. And that means x less than 40 less than y. And they're both square numbers because they have to be square rooted and they're whole numbers. So which two consecutive squares can x and y be? So let's see. 36 is the one closest to 40 but less than it. And after 36 comes 49. It satisfies that, and that means root of 36 less than root 40 less than root 49. And now we can erase the x and y and substitute the actual values in. And now root 36 is equal to 6 because whole number, we're not adding negatives. And root 49 is equal to 7. So that's the answer. Question 18. Carlos, Rajiv, Samira, and Naomi share a bag of sweets. Carlos eats 2/5 of the sweets. Rajiv eats 1/6 of the sweets. Samira and Naomi share the rest of the sweets equally. Work out the fraction of the sweets Samira gets. Okay, so the bag of sweets is equal to 1 part. So 1 minus 2 by 5 is equal to 3 by 5. That's the remaining after Carlos eats it. And then 3 by 5 minus 1 by 6. Now we can make a common denominator. It's equal to 3 into 6 minus 5 into 1 by 5 into 6, which is 30. And that's equal to 18 minus 5, which is 13 by 30. And then 13 by 30, the whole divided by 2, that's equal to 13 by 60. Because Samira and Naomi shared equally, we're dividing it by 2. And 13 by 60 is a fraction of sweets that Samira gets. So that's the answer. Question 19. The first three terms of the sequence 3n squared minus 7n are -4, -2, and 6. Write down the first three terms of the sequence 3n squared minus 7n plus 3. So you notice it's actually this whole thing plus 3, which means each term has to be added 3. That means -1, 1, and 9. That's the answer. Question 20. Mike conducts an experiment to find out if cars drive at different speeds on different days. He collects data about the speeds of cars on the road between 12 p.m. and 1 p.m. on 2 different days. And these 2 days are Monday and Thursday, but this doesn't matter much. His data is shown in the back-to-back stem and leaf diagram. A. Work out the difference in speed between the fastest car on Monday and the fastest on Thursday. Remember, you have to see the key over here if you want to understand it easier. Fastest car on Monday is 83. Not 38, but 83. Look at the key. Fastest car on Thursday is 84. So 84 minus 83 is equal to 1 kilometer per hour difference. So that's the answer. B. Mike concludes that the speed of cars is lower when there are more cars on the road. Explain how the data supports Mike's conclusion. Over here, we have Monday, and there are much less cars on the road. Right here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cars on the road. And over there, we have most of the cars above 50 kilometers per hour. That's 9 cars. So there are 9 cars above 50 kilometers per hour on Monday. And now we can look at the same thing on Thursday. So first, how many cars? 2, 5, 10, 15, 18, 19, 20, 22 cars. So that means out of these 22, these are not there, but above 50 kilometers per hour is this, meaning 3, 4, 6, 7. So 7 cars above 50 kilometers per hour on Thursday. And number of cars on Thursday is 22. And number of cars on Monday, as we saw, is 12. And this is a higher proportion than this. And therefore, Mike's data supports his conclusion. Question 21. Hassan plays cricket. The table shows the number of catches he makes in 50 games. A. Use the table to estimate the probability that he makes exactly 1 catch in the next game he plays. So over here, we have the frequency 11 for 1 catch, and there's total of 50 games. And that means it's 11 by 50. B. Write down the modal number of catches. That means number of catches which has the highest frequency. That's 13, so number of catches is 3. And that's the answer. C. Find the median number of catches. So first, need to find the median of 1 and 50. That's 1 plus 50 divided by 2. That's equal to 25.5. So where do we have either the 25th or the 26th catch? Because 25.5 is not a whole number, you can't have half a catch. So 25th or 26th, let's see where that comes. So 8th, 19th, and over here we have the 31st, which means that in the 2 number of catches, we have the 25th and 26th catch. Therefore, the answer is 2. Question 22. The hamster eats 2 by 7 of a bag of carrots each day. Work out how many days it takes the hamster to eat 8 whole bags of carrots. So we need to find 8 whole bags of carrots. So 1 bag can also be written as 1 whole, which is 7 by 7 here. This is 2 by 7, and if you will make 7 the denominator and 1 bag, we can make it 7 by 7. So 8 bags is equal to 7 by 7 into 8, which is equal to 56 by 7. And then a hamster eats 2 by 7 of a bag of carrots each day, which means that how many days will it take? It'll take 56 by 7 divided by 2 by 7, which is equal to 56 by 7 into 7 by 2. Now we can cancel out the 7s. 56 by 2 is 28 days. So the answer is 28 days. Question 23. A equals 4 and t equals negative 3. Work out the value of 5at squared. That's equal to 5 into 4 into negative 3 the whole squared, which is equal to 5 into 4 into 9. And now that's equal to 20 into 9, which is equal to 180. So that's the answer. Question 24. Mia has 2 ribbons. One is 60 centimeters long, the other is 45 centimeters long. Mia cuts both ribbons into pieces. All the pieces have the same length. And the greatest possible length of each piece of ribbon. That means because she cuts the ribbon into pieces and they have the same length. It is the HCF of 45 and 60 centimeters. So let's find the HCF like this. So first there's a 3, 15, and 20. And there's a 5. So 3, 4. So 3 into 5, which is equal to 15 centimeters, is the greatest possible length of the piece of ribbon. That's the answer. Question 25. Here's a number fact. 56 into 94 equals 5264. Use this fact to work out these calculations. 5.6 into 0.94 equals dash. First we see 56 into 94 is equal to 5264. 5.6, that's 1 decimal place. That's a 6. It's 1 decimal place. 0.94, there are 2 decimal places. We need 3 decimal places in 5,264, and that means it's 5.264. Next we have 5264 divided by 0.56. Now 5264 divided by 56, when you bring it here, it's equal to 94. If we divide by 0.56, it's equal to 94 into 100, because when we divide by a smaller number, the answer increases. 94 into 100 is equal to 9,400. That's the answer. Question 26. Trains travel between two stations. The distance between the two stations is 200 kilometers. The average speed of two trains is shown in the table. Calculate the difference between the journey times of two trains. Give your answer in minutes. So if this is 100 kilometers per hour for train A, that's equal to 200 kilometers divided by 100 kilometers, because distance by speed, that's equal to 2 hours. Remember, this kilometers per hour. Next, 200 kilometer divided by 80 kilometer per hour. If you calculate, it'll be equal to 2.5 hours, which is equal to 2 hours 30 minutes. So difference is 2 hours 30 minutes minus 2 hours. We can cancel the 2 hours out, and that's equal to 30 minutes. So that's the answer. Question 27. Write these numbers in order of size, starting with the smallest. First, let's make these into normal numbers. That's equal to 48 and then 2 zeros. That's 4,800. And then that's equal to 0.16, the next one. The third one is equal to 7 into 10 to the power of 3. Because 10 to the power minus 3 is equal to 1 by 10 to the power of 3. And we're dividing it. Therefore, 7 to 10 to the power of 3, which is equal to 7,000. And then 175,000 divided by 10 to the power of 4, 17.5. So the smallest is 0.16, 16 into 10 to the power of minus 2. Next, this fourth one, which is 175,000 divided by 10 to the power of 4. The next is the first one, which is the second largest, 0.48 into 10 to the power of 4. The largest is 7 divided by 10 to the power minus 3, which is 7,000. So that's the answer. Question 28. The diagram shows an object A and an image B. A can be mapped onto B using a rotation center, which is 0, 0, the origin right there, followed by a different type of transformation. Complete the description of the two transformations. First transformation, rotation dash degrees, and which side, anti-clockwise or clockwise. And then the center is 0, 0, as we already know. And then the second transformation, description, full thing, we need to write it. First, we'll mark the point and see how we can rotate this so that it forms a shape which is somewhat like this, but it can be over here or it can be over here. It'll be somewhere different. And that means we need to translate it to make it over here. So we know that the second transformation is translation. Now we need to find the vector of that. But to find the vector, we need to do the first transformation, which is rotation. So we rotate this way, which is anti-clockwise. And we rotate it 90 degrees. This line turns over like this, and that's this line over here, which is 1 unit long. And that means we can check it with the other lines. It'll be like this, like this. That means it's a 90-degree anti-clockwise. So let's write that. Now we need to find out where this shape ends up after you rotate it. So this point will come right there. And we can use that as a foundation. And use the other points corresponding. And you can make it like this. So this is where the rotation will be. So let's draw that now. Alright, so you've drawn shape A, which is transformed by rotation. But now we need to translate it up here. Let's take this point right here and see how far we need to go to come here. So in the x-axis we go 1, 2, 3, 4, 5, 6. 6 in the x-axis and 1, 2, 3, 4, 5, 6, 7 in the y-axis to get to shape B. And therefore the vector is 6, 7. That is the answer for this question. And now we've come to the end of our paper. So hope you liked this video and hope you enjoyed it. Hope you also learned something new from it. And that brings us to the end of our video. So I'll see you in my next one. Bye.